1931, the United States still had no federal interstate highway system. Rough, sun-baked, dust-choked dirt roads were the true battlefield of machinery. There, every mile was a trial, not meant for weak-hearted engines or impatient men. One side was General Motors, the industrial giant with the ambition to take diesel out of the factory and put it on wheels. Their engines, later known by the name Detroit Diesel, screamed, revved high, and responded quickly, carrying the spirit of domination born in laboratories and assembly lines. The other side had only one man, Cummins. No white lab coat, no massive team, just a driver who believed that diesel did not need to be the fastest, but had to survive the longest. Then he brought an engine originally built for a tractor to the Indianapolis 500. 500 continuous miles, no fuel stop, consuming exactly $1.40 worth of fuel oil. From that moment on, a question was posed for the century that followed. In American machinery, is speed or endurance the ultimate truth? Let us return to 1919, when diesel had not yet taken on the shape of freedom. It existed as massive blocks of iron fixed in power plants, ship holds, or sawmills. Diesel was powerful but slow, and to most engineers of the time, putting diesel into a moving vehicle was a far-fetched, even dangerous dream. Excessive vibration, difficult starting, and a power-to-weight ratio far too low for wheels. In that context, General Motors entered the game with the full arsenal of an industrial empire. GM had capital, vast research facilities, and formally trained minds capable of turning diesel into a product that could be measured, standardized, and replicated. To them, every engine was a calculation. How many horsepower per pound, what engine speed was optimal, and how to control every variable before it ever left the assembly line. On the opposite side, there was almost nothing beyond a single human being. Cummins was not an academic engineer, nor a corporate manager. He was a driver and a mechanic, working for a wealthy family in Indiana, and was given a $50,000 backing, a modest sum compared to GM's R&D budget. His philosophy was therefore very different. Clessy did not ask how much peak horsepower an engine made, but whether it would start on a cold morning. He did not care about RPM charts, but about whether it could run for hours, for days, without demanding constant attention. While GM sought to conquer diesel through science and control, Cummins approached it through the instinct for survival. The confrontation between Cummins and Detroit Diesel truly entered a new chapter when the question was no longer who built better diesel, but how diesel should breathe and fire. Two-stroke or four-stroke. That choice split an entire mechanical world in two. At General Motors, the man who laid the foundation for this bold direction was Charles Boss Kettering, the chief architect of GM's engineering mindset. His philosophy was often misunderstood as reckless, but in truth, it was what mechanics call intelligent ignorance, a willingness to break doctrine when real-world results proved otherwise. From that thinking, Detroit Diesel gave birth to the Series 71, a two-stroke diesel engine forced to breathe through a Roots supercharger. The result was a machine that was lighter, more compact, quicker to respond to the throttle, and capable of higher revs than any diesel of its time. But the price was sound. The howl of the blower became its acoustic signature, the thing that later earned it a name spoken with both affection and caution: Screaming Jimmy. On the other side, Cummins did not waver. They remained loyal to the four-stroke engine, heavier, slower, but easier to control in terms of heat and efficiency. For Cummins, every combustion cycle had to be fully utilized. High revs were unnecessary, only steady torque and the ability to run continuously mattered. When World War II broke out, the Detroit Diesel 671 engine was widely used in landing craft during the Normandy invasion, where quick response, lightweight, and instant acceleration were matters of survival. In contrast, Cummins engines appeared quietly in generators, radar stations, and field hospitals, where the only requirement was simple: run without stopping, day after day, with no permission to fail. Entering the 1950s and 1960s, the interstate highways stretched across the nation. Trucks no longer crawled along dirt roads, but charged forward hundreds of miles each day. In that era, Detroit diesel seemed almost born to dominate. The constant howl of the Roots supercharger defined the soundscape. The Series 71, and later the 92, screamed as the tachometer needle crossed limits traditional diesels had never reached. Drivers liked them for their light feel, quick response, and easy pull. Fleet owners liked them because parts were interchangeable, and repairs could be done quickly on the roadside. Detroit diesel became the unofficial standard for long-haul buses, trucks, and all kinds of heavy equipment. But the Screaming Jimmy had a dark side as well. A two-stroke engine breathing through a blower never got tired, and sometimes never knew how to stop. The phenomenon of runaway became a nightmare for drivers. When the engine began ingesting its own lubricating oil through the intake, engine speed climbed out of control even after the fuel had been cut. In those moments, mechanical knowledge was no longer theory, but survival instinct. The only way to save the engine, and sometimes oneself, was to completely block the air intake with rags, jackets, or anything within reach. Some engines survived, others simply exploded. And as engines grew more powerful and trucks grew heavier, a deadly problem gradually emerged: how to stop 80,000 pounds of steel charging down a long mountain grade using drum brakes that had been designed for a much slower era. For years, drivers had only one option: ride the brakes, pray, and hope the smell of burning linings did not turn into disaster. For Clessie Cummins, this was not a theoretical problem. In 1931, on Cajon Pass in California, he nearly lost his life when a heavy truck exceeded the limits of its braking system. Clessie's solution was simple, yet bold. Instead of allowing the engine to serve only as a source of propulsion, he turned it into an air compressor. By opening the valves at precisely the right moment, the engine no longer pushed the vehicle forward, but dissipated energy, creating smooth, stable retarding force independent of wheel brake friction. This was not braking, but true engine braking, something drivers would later regard as a savior. Ironically, Cummins, as a company, was not enthusiastic about the invention. They feared legal liability, feared complexity, and feared change. Clessie, pragmatic and unsentimental, sold the idea to Jacobs Manufacturing. From that point on, the world came to know it as the Jake brake. Entering the sharply upward, it overturned the entire technical order of the transportation industry. At that point, two-stroke diesel engines began to reveal a fatal weakness. Detroit diesel, with its Series 71 and 92 engines, consumed more fuel when forced to operate continuously under heavy load. Two-stroke engines generated significant heat and required the blower to push air non-stop. And when fuel became expensive, every former advantage suddenly turned into a burden. On the other side, Cummins launched its answer in the form of the Big Cam, the NTC855 series. The camshaft diameter was increased from 2.0 to 2.5 inches to better handle load, and the high-pressure fuel injection system allowed for cleaner, cooler combustion. And Cummins also suffered a painful misstep. The V555 triple nickel, an attempt to imitate Detroit's V-configuration engine to capture military market share, became a technical disaster. Hot-running, complex, and failure-prone, it proved that Cummins was strongest when it stayed true to itself, not when it chased its rival. The most brutal test took place in Australia's outback, where drivers hauled 3 or 4 trailers across the desert in temperatures exceeding 100 degrees Fahrenheit. This was the kill box, a place where engines were not allowed to be weak. Under those conditions, many two-stroke Detroit engines were cooked by heat and sustained pulling loads. By contrast, the Cummins KTA-19, a massive 19-liter machine, quietly crossed the 1 million-mile mark without requiring a major overhaul. Entering the 1980s, Detroit diesel was known by a harsh nickname, Green Leakers. The Green Leakers. Oil stains on shop floors, exhaust smoke, and declining reliability drove customers away. Market share fell to around 3%, and many believed the Detroit diesel era was over. In 1988, a figure entered the story, with a mindset unlike that of any traditional engineer or corporate manager, Roger Penske. He acquired 60% of Detroit diesel, not out of nostalgia, but because he saw one simple truth. The product was not dead, but the culture had rotted. Penske did not begin with engines. He began with the factory floor. The entire plant floor was painted pure white. The reason sounded almost ridiculous, so that any drop of oil that fell could not escape the eye. Every process was tightened, every detail traced back to its source, every small flaw treated as an offense. The results did not come immediately, but they came with certainty. Detroit diesel began to reclaim its reputation for durability, tightness, and consistency. More importantly, the company prepared for a major turning point, abandoning its personality-filled two-stroke past to enter the modern four-stroke world. In the early 1990s, Detroit diesel launched the all-new Series 60. With its inline-six, four-stroke configuration, it acknowledged a truth that Cummins had proven for decades. 6 cylinders in a straight line deliver the best mechanical balance, crankshaft durability, and thermal efficiency for long-haul trucking. The heart of the Series 60 was Detroit diesel electronic control, an integrated electronic control system introduced earlier than most competitors. The ECU did not only control fuel injection, but also managed timing, limited engine speed, diagnosed faults, and protected the engine from impatient drivers. This was a diesel that knew how to protect itself. Optimized cylinder head flow design, oil-cooled pistons, and a thick cast block allowed the Series 60 to run hundreds of thousands of miles with high stability. By 1993, Detroit diesel's market share surged to approximately 33%. And the appearance of the black box, the ECU, changed American diesel in the most profound way since the engine first left the concrete floors of the factory. For Detroit diesel, the Series 60 became the perfect foundation for a new era. The DDEC system was not merely fuel injection control, but a true brain. It remembered driver habits, monitored temperature, pressure, and engine speed, and automatically intervened when the engine was abused. For the first time in American trucking history, a diesel engine could talk to a mechanic through fault codes rather than smoke or knocking sounds. The Series 60 quickly surpassed 1.2 million units sold, becoming the benchmark for smoothness, stability, and consistency. On the Cummins side, the answer was called the Cummins N14 with the Select system. If Detroit used electronics to control, Cummins used them to unlock potential. The N14 retained the mechanical foundation of the legendary 855 series, but the ECU allowed power to be tuned to real-world needs. An engine could leave the factory rated at 430 horsepower, then, through programming alone, be raised to 460 or even 500 horsepower without any hardware changes. Entering the late 2000s, American diesel moved into a period many drivers bluntly called the tied hands era. The new emissions regulations of the Environmental Protection Agency were no longer recommendations, but mandates. From the 2007 to 2010 milestones, diesel engines were forced to become far cleaner, and the price paid was unprecedented complexity. New terminology quickly became a source of dread. EGR to lower combustion temperatures, DPF to trap soot, and DEF/SCR to treat exhaust gases with chemicals. In theory, everything made sense. In practice, engines ran hotter, grew heavier, and became more dependent on sensors and software than ever before. Reliability, once the pride of American diesel, began to erode, especially for long-haul, heavy-load operators far from service centers. This shift forced the two major names to choose two different paths. Detroit Diesel, now under Daimler ownership, chose full integration. The engine no longer stood alone, but became part of a closed ecosystem. Engine, transmission, axles, and software designed to communicate with one another. The goal was no longer raw power, but smoothness, fuel optimization, and consistent emissions compliance. For Detroit, the truck became a tightly controlled machine from start to finish. By contrast, Cummins maintained its independent position. They continued to act as the mercenaries of the American trucking industry, supplying engines to Kenworth, Peterbilt, and many other manufacturers. Cummins' philosophy changed little, a focus on pulling power, durability, and the ability to work under conditions that regulations do not always fully reflect. This made them more flexible, but also forced them to carry greater pressure in meeting emissions laws across many different configurations. The confrontation between Cummins and Detroit Diesel was never just about technical superiority. It was a journey through which American machinery defined itself. One side was born from survival experience, from long grades and night runs with no escape. The other grew up with systems, discipline, and the ambition to control every variable.